Okay, so this is another sinusoid example. We've got, in this case, a spring in two-mass system oscillates according to x1 of t is 5 sine of 3 pi over t plus pi over 6, and x2 of t is 10 cosine 3 pi over t minus pi over 3, where x1 denotes the horizontal displacement of the first mass, x2 denotes the horizontal displacement of the second mass, and then it wants to know the elongation of the spring connecting the two masses is given by sigma of t, which is just x2 minus x1. And it wants to combine that as a single sinusoid. So similar to the circus problem we did before, we had to combine them. Only the difference is this time that we actually have a phase shift or a phase angle associated with each of the different parts. And so that complicates our solution quite a bit. So again, just kind of a picture of what's going on. We've got a spring here, we've got a mass at each end. They're both oscillating back and forth, back and forth. The displacement of this one is x1, the displacement of that one is x2. And so as those both move, the spring's getting longer and shorter. We want to combine that together and kind of keep up with the distance of it as a whole. And so we've got the functions that dictate each one, and we want to combine that into one big function which dictates all of the spring together. So again, because we have these phase shifts or phase angles associated with each one, we can't just use the same method we did before, but we can use the same concepts in that if we look at each angle or look at each displacement, we have x1 is equal to 5 times sine of 3 pi t plus pi over 6. And again, we know this can only work because omega is the same for both these. In other words, it's 3 pi here and it's 3 pi there. That's the only reason this is going to have a chance at working. So if we do this and use the same ideas that we did before in terms of we're going to use our sine addition formula because we've got the value of a sine addition value there, so that we can rewrite this as x1. Sine addition tells us that sine of x plus y equals sine x cosine y plus cos x sine y. So this can be rewritten as we're going to have this factor of 5 out front. Sine of, I want to put this in brackets so that I don't get confused by what's in parentheses. Sine of x, so sine of 3 pi t times the cosine of pi over 6. So again, I'm letting this be my x and this be my y in terms of rewriting. Plus cosine of x, so that's cosine of 3 pi t times the sine of y, which is pi over 6. So I can rewrite x1 is 5 cosine pi over 6 times sine of 3 pi t plus 5 sine of pi over 6 times cosine of 3 pi t. And I can simplify that a little bit more by knowing that cosine is, of course, the same as 30 degrees. By going to my unit circle, I know that the cosine of 30 degrees is square root of 3 over 2. So this is 5 square root of 3 divided by 2 times sine of 3 pi t. And that the sine is 1/2. So this is 5/2 cosine of 3 pi t. And that just gets me x1. So I'll single underline that because that's going to be useful later, but not ultimately an answer. Similarly, for x2, we said is 10 times the cosine of 3 pi t minus pi over 3. So we're going to use cosine subtraction. And the cosine subtraction formula, if we go back to our handy sheet, tells us that cosine of x minus y is equal to cos x cos y minus sine x sine y. And again, that's not something I would expect you to have memorized, but hopefully you're putting it on your reference sheets or having your reference sheets so that you can access that quickly. So if I rewrite this in terms of that, remember this is going to be x, this is going to be y. So this is x2 is 10. Got to keep my amplitude out front. Cosine of x, so cosine of 3 pi t times the cosine of y, so that's cosine of pi over 3, minus the sine of x, so sine 3 pi t, times the sine of y, so that's sine of pi over 3. And again, distribute to 10 and kind of rearrange some things. So 10 times cosine of pi over 3 times cosine pi t minus 10 times the sine of pi over 3 times the sine of 3 pi t. Again, it's nice that the shift that they gave us is something that's on our unit circle. So I can remember that cosine of pi over 3, check my unit circle, cosine is 1/2 for this one, so this one is 5 cosine 3 pi t. Minus, I'm sorry, this was plus. This is why you got to be careful with those things. So minus, this is plus, these should all be plus in the middle. So this is plus 10 times the square root of 3 over 2, so that's really 5 square roots of 3. Times the sine of 3 pi t. So I've got these two things. I've got them divided by the sine and cosine. I'm actually going to rewrite it one more time. I believe this is 10 times the square root of 3 over 2, just so you guys will see where that came from. And then I'm going to rearrange it just because my other function had sine first, and when we did our previous problem, we had sine first to kind of put it back in things. I'm going to rewrite it as x2 is 5 times the square root of 3 times the sine of 3 pi t plus 5 times cosine of 3 pi t. And I guess I should be keeping those in parentheses so that you know it's cosine of that whole part, or sine of that whole part. And that way those will kind of line up, which will be very useful in a minute, because the next thing is the elongation, remember, is x2 minus x1. So if it's x2 minus x1, then we just kind of look at the combined terms. So line them up. x2 is 5 times the square root of 3 over sine 3 pi t plus 5 cosine of 3 pi t. And I should say, if you don't remember, if you don't have a unit circle with you and you don't remember these are 5 square roots of 3, if you do it as a decimal, you know, if you just punched in your calculator, you did cosine of pi over 3, and you remember to do it in radians, and got that number, and it turned out to be 8.6 or whatever, that's fine. You can use 8.6 through there, and it'll work out. I'm going to subtract x1, which is 5 square roots of 3 over 2 times sine of 3 pi t plus 5 halves times cosine of 3 pi over t. So when I do that subtraction, remember I am subtracting it, not adding it. So do the subtraction. So I end up with that minus half of that is half of that. And again, this is where it might make just as much sense to have changed myself to decimals by now. But now I've got elongation as a function of t as a sine term and a cosine term, and I can remember using sine addition, that this looks like a cosine of phi times sine omega t plus a sine phi times cos omega t. So I know that omega is 3 pi. We knew that from the beginning. That's the only reason it works is because omega of each of them is 3 pi. The omega of my answer is going to be 3 pi. That my angular frequency is going to be 3 pi. And we learned from that so a cosine phi is going to be 5 square root of 3 over 2, and a sine phi is going to be 5 halves because these match up there. And again, as you're writing homework, you don't necessarily want to draw those arrows, but yeah, these things match up. And so the way I got A is by using the Pythagorean theorem. So I get that A is 5 square root of 3 over 2 squared. Again, this would be a good time to start punching things into a calculator. What we get 25 times 375 plus 25 what I'd actually get, let's actually just do this. This is 75 over 4 plus 25 over 4. So that's the square root of 25. So it's actually equal to 5. So probably not a coincidence that they used the numbers they did. I get an amplitude of 5. And I get that phi, of course, is the tan inverse of the sine value. So 5 halves divided by 5 over 5 square root of 3 over 2. So that's the same as the tan inverse of 1 over the square root of 3. So what angle gets me 1 over the square, or no, I'm sorry. Yeah, tan inverse is 1 over the square root of 3. So what angle gets me 1 over the square root of 3? The answer is 30 degrees. Or pi over 6 radians. Double check that with a calculator before I move on. Have all this screwed up. Yeah, so 30 degrees or pi over 6 radians. And so I almost fit it on a page, but didn't quite. So if we keep that information there. So now I know that sigma of t, the elongation is a, which is 5.00 times the sine of omega, which is 3 pi, times t plus phi. So plus pi over 6. And that was a really complicated problem with an only somewhat simple answer. And so it's probably a good idea to check so if I do it at 0, I get 5 times the sine of 0 plus pi over 6. So I get at time 0, the displacement should be 5 times the sine. And again, make sure you're in the right units. So I get that it's 2.5 meters. And if I check it against what is x1 of 0 is from the original 5 times the sine of 3 pi t plus pi over 6. So 0x1 is equal to 5 times the sine of pi over 6. So it's 2.5. x2 is equal to x2 at 0 at time 0 is equal to 10 times the cosine of 3 pi, well, cosine of this part is 0 minus pi over 3. So x2 is equal to 10 times the cosine of negative pi over 3. which is 5. So x2 at 0 minus x1 at 0 equals 5 minus 2.5 equals 2.5 meters. So good at time 0. And then another time would be able to check at time 1. So at 1 second, we have 5 times sine of 3 pi plus pi over 6. So that's 5 times the sine of 19 pi over 6. Again, I could subtract out the parts that are 2 pi. Or I can just punch in my calculator and go with it and let it worry about getting the concurrent angles. It tells me that this part is negative 2.5. And if I check it for x1 of 1 is 5 times the sine of 3 pi t times 1. So interestingly enough, it did not something necessarily would happen on purpose. What we found out is that the value x1 turned out to be the same as our total displacement, which is somewhat strange. The elongation works out to be that way. X2 at 1 is 10 times the cosine of 3 pi minus pi over 3. And so x2 is 10 times the cosine of 8 pi over 3. And so if we do it that way, we know that v of 1 is x2 of 1 minus x1 of 1. And so it's negative 5 minus negative 2.5. And we also get negative 2.5 meters for there as well. So it worked at least 2 points. It doesn't prove that it works all the time, but it's a pretty good indicator that hopefully we got the right thing going on. So yeah, very lengthy problem. But again, if we just break it down piece by piece, we can eventually get there.